नमस्कार दोस्तों, मेरा नाम सुरेंद्र कुमार है और मैं अजय कुमार इंजीनियरिंग कॉलेज में कंप्यूटर साइंस डिपार्टमेंट में असिस्टेंट प्रोफेसर हूँ। तो आज का हमारा टॉपिक है अलजेब्रिक स्ट्रक्चर, जो कि बेसिकली यूनिट 4 डिस्क्रीट स्ट्रक्चर एंड थ्योरी ऑफ लॉजिक सब्जेक्ट से लिया गया है। एकेटी में बीटेक थर्ड सेमेस्टर क्लासेस के लिए ये कोर्स रन करता है। तो हम बात करने वाले हैं आज अलजेब्रिक स्ट्रक्चर की। सो अलजेब्रिक स्ट्रक्चर बेसिकली जब हम किसी सेट थ्योरी पे वर्क करते हैं तो नंबर ऑफ सेट्स पर हम बात करते हैं और नंबर ऑफ सेट्स के लिए डिफरेंट काइंड्स ऑफ प्रॉपर्टीज डिफाइन होती हैं, उनको हम कुछ इस कैटेगरी में रखते हैं। तो हम बात करते हैं व्हाट इज बेसिकली अलजेब्रिक स्ट्रक्चर। उससे पहले हम बात करेंगे हिस्ट्री ऑफ ग्रुप थ्योरी, बिकॉज ये अलजेब्रिक स्ट्रक्चर जो है वो ग्रुप थ्योरी को डिफाइन कर रहा है यहाँ पर। तो हिस्ट्री ऑफ ग्रुप थ्योरी की बात करते हैं तो बेसिकली इट्स ए मैथमेटिकल डोमेन दैट स्टडी ग्रुप्स इन वेरियस फॉर्म्स that has evolved in various parallel threads like group theory, then the theory of algebraic equation, or you can say it is a number theory, or you can say it is geometry, or you can say it is Joseph Louis Lagrange or Niels Heinrich Abel were early research in the field of group theory. As we talk about the modern algebra, so modern algebra evolved from the set theory, vector space, group theory, field theory, and ring theory. So these are the subjects, these are the topics for the modern algebra. Now, what are the main applications of group theory? So group theory basically a branch of abstract algebra and has applications in various fields including mathematics, physics, chemistry, computer science, and cryptology also. Here are some key applications. We can talk about the crystallography in group theory, which is basically used to analyze and describe the symmetric properties of crystals in chemistry. It helps us understand and predict the physical property of crystal and based on their symmetrical arrangement. In molecular chemistry, the group theory is applied to the study and symmetries of molecular structure. It aids in predicting molecular vibrations, electronic states, and spectroscopic properties of group theory. In particle science, elementary particle classification is based on group theory. In coding theory, we can say error correcting and code and detecting code is basically work with the group theory concept. Next is cryptography. We generally use public key cryptography in group theory concept, particularly those related to modular, arithmetic, and finite fields are foundational to some cryptographic algorithms. For example, security of certain public key crypto systems relies on the difficulty to solve the mathematical problems associated with the certain groups. Geometry and topology basically transformation groups and knot theory works with the group theory. So these are the number of application of group theory in number theory, in physical and quantum mechanics, in graph theory, that is graph isomorphism. So these applications highlight the various versatility and importance of group theory across various scientific and mathematical disciplines. So its ability to describe and analyze sometimes symmetrics makes it a powerful tool in understanding complex structure and phenomena. Now, what is an algebraic structure? If we describe it in algebraic structure, so basically a non-empty set G. So we are talking about the non-empty set G, right? With one or more binary operation. It contains one or more binary operation. So binary operation means that works on two operands. So a set with one binary operation, one or more binary operation, is said to be algebraic structure, How? Suppose star is a binary operation. It is not like multiplication. It is a star general binary operation. So G star will be an algebraic structure, and here are some different kinds of algebraic structure with different properties, like algebraic system, semi-groups, monoids, groups, and abelian groups. These are the numbers which contains property 1, property 1 and 2, property 1 and 2 and 3, property 1 and 3, 4, property 1 and 4, 3 to 4, 5. So we will define on the basis of property these algebraic systems into different kinds of groups. So let's study the 5 properties which works with the algebraic system. First one is closure property. Second one is associative property. Third one is existence of identity. Fourth one is existence of inverse, and fifth one is commutative property. So these are the 5 important properties which describe different kinds of algebraic structures. Now we work with the algebraic structure. For example, we have a natural set n, set of all natural numbers. Again, we have a set z, set of all integers. We have a set q, set of all rational numbers. Now we have set r, set of all real numbers. So what these are the sets. If we talk about the binary operation, the binary operation star is said to be a binary operation. That means it's closed operation on a non-empty set A. If we say A star B belongs to A, for all A B belongs to A, that is called closure property, then only it is called a binary operation. I hope you understand. These are 2 elements of set A, small a, small b, and we apply these binary operation, and applying after the binary operation on these 2 elements, the result is also belongs to the set A. That means it is closed in set A, result also, right? So this is called closure property. So the set n is closed with respect to the addition and multiplication. So how this statement is true? You are saying the set of all natural numbers n is closed under the addition and multiplication, but we did not say here minus, subtraction and division. We examine how this statement is true. For example, we have set n and the elements of the sets are 1, 2, 3 and infinite. So if we apply these elements with the binary operation plus, so 1 plus 4 will be equal to 5, and this again belongs to set n. Okay. Next, for example, 12 plus 35, that is 47, again belongs to n, and here this is also belongs to n, and this is also belongs to n. That means it is satisfying the property A star B belongs to A. For every AB belongs to A. So you can go for any number up to infinity, you will find all the result will also lie or belongs to n. That means you can say this set n is closed with respect to addition. Again we apply multiplication. So 5 multiply 6 equal 30, that is belongs to n. Or you can say 10 multiply 248 equals 2480, again belongs to n. So, in this way you can take any number and multiply those number and you will find the result which is already existing in set n. So, you can say the multiplication property or the binary operation multiplication is also is closed with respect to the set n, right. But as I told you, the subtraction and division doesn't belongs or is not satisfy the closure property on n. Why? Because if you apply subtraction operation, then 5 minus 2 equal 3 is okay, but you reverse the order, 2 minus 5 it will give you minus 3, which doesn't belongs to n. So, here the property, the closure property fails. That is why you are restricting this set n is closed with respect to addition and multiplication. In the same way, if you divide 3 by 2, it will give you 1.5, which doesn't belong to n. So, in this way you can say the algebraic structure is set n on addition and multiplication only, right. I hope you understand. Now, we can have different kinds of sets which are algebraic system or algebraic structure. So, here we have defined that n plus is algebraic system because natural number on addition is algebraic structure. Z plus and minus both are defined on system Z, that is set of all integers including 0. R, that is set of real numbers, is algebraic system on plus, multiplication and subtraction, but not on division, right. Now, properties are commutative properties. Some properties are on algebraic system are commutative. That means A star B equals B star A for all A B in A. We say about the associative property, that means A star B star C will be equal to A star B star C. And the same way we can say identity property for an algebraic system A star, an element E must exist in A is said to be an identity or element of A if it is like this. That means A operation with E will be equal to E operation with A and will give you again A for every element in A. This is called identity property. That means you can understand it as A multiply by 1 equal will give you always A. यानी 1 में आप कोई भी मल्टीप्लाई करेंगे वो हमेशा वो सेम ही नंबर देगा. तो फॉर मल्टीप्लिकेशन 1 is identity, and if you say for addition, so A plus 0 will always give you A. So for addition it is 0, identity is 0. So identity is changed as per the operation, given binary operation. If it is given multiplication operation, then for a particular system it is 1, and if it is addition operation, then for a particular set it is 0. Next is inverse. Inverse means if you have an identity in your set A with binary operation star, let A be an element in A, and element B is said to be inverse of A if if you find A operation B equal to B operation A equal to identity, means after applying the operation on B with A, you will find identity. Then you can say B is inverse of A. You can say B is inverse of A, right? So these are the properties which are helpful to identify which kind of algebraic system you are using, or you can recognize the given set on particular operation is define which kind of algebraic system. In this study, we have one special algebraic system that is called semi-group. So what is a semi-group? Semi-group is basically an algebraic system A star. It is said to be a semi-group if it is closed operation on A, if it star is a closed operation on A. Second, if it is associative operation for all A, B, C in A. So as earlier I have shown you a diagram, you can go previous slide. So having closure property, it is algebraic system. Having closure with associative, it is a semi-group. So a semi-group is an algebraic system which have two properties, closure and associative. So here is an example. N plus is a semi-group or n multiply is a semi-group. N is a natural number, but n minus any n on subtraction is not a semi-group because it is not closure. I already discussed the example. If I use 5 minus 2, it will give you 3, belongs to n. But if I use 2 minus 5, it will give you minus 3, which doesn't belongs to n. So n on minus is not a semi-group, right? Next structure is monoid. So monoid is an algebraic system. A star is said to be monoid if it holds the following conditions, like one is closure, second is associative, and the third is there should exist an identity in A. So monoids, so that set n is a monoid with respect to multiplication. How we can say? Here n is 1, 2, 3 closure property because it gives the closure property. Already I have discussed. It gives then associative with multiplication. Already we have discussed. If we say identity, so there exists 1 in n such that if we apply 1 multiply A equals 1, A multiply 1, then we will always get A. Or A is for all belongs to A belongs to n. That means it contains also an identity. So it is a monoid. N multiply is a monoid. But n plus is not a monoid because the 0 doesn't exist in natural set. Understand? Because for plus it should be 0 and 0 doesn't exist in n. So identity वहाँ exist ही नहीं करती आपके पास में. Next, semi-group, sub-semi-group and sub-monoid. So let S star be a semi-group and let T be a subset of S. If T close under the operation star, then T star is called a sub-semi-group, right? So n multiplication is a semigroup and T is a set of multiples of positive integers m. So T star T dot is again a sub semigroup. In the same way, the submonoid, let S be a monoid S star with identity E, and let T be a non-empty subset of S. Then T is closed under the operation star and E belongs to T. Then T star is also called a submonoid, right, of S star. Next, the final definition of group is group. An algebraic system G star is said to be a group if the following conditions are satisfied. First one is closed operation. The star must be in closed operation. Second one is an associative operation. Third one, there must exist identity element in G. And the fourth one, every element in G has inverse. So, inverse, I already have discussed about the inverse. If you have an element A and another element B, and by applying a star operation on A and B, or B or A, you will find E and the element. So, this is called a group. Next is abelian group. If G star is a abelian group, how? If it also satisfies the property of commutative. That means A star B equals B star A, then we call it as an abelian group. So I hope as we have categorized different kinds of algebraic system, and you will have a better look on how we can recognize which is semi group, which is monoid, which is group, and which is abelian group. Thank you so much.